So let's continue with the coordinate points of ellipse. So since we're already done with a equal to 10, then b equal to 6, then we're going to solve for the focus or the foci here. So if you have already 100 or a, then you already have b for 36, then we're going to look for c. Remember, a while ago, the formula for solving for c equal to square root of a squared minus b squared. So therefore, 100 minus 36, that will be square root of 64, and the square root of 64, that will be plus minus 8. Since you have already plus minus 8, the distance from center to the focus, the focus 1 and the focus 2, that will be changes in excess. So therefore, 8 plus 3, that will be 11, and 3 minus 8, that will be negative 5, 4. Then you also have the latus rectum. The latus rectum equal to b squared over a, or 36 over 10, or simplify as 18 over 5. So therefore, this will change in y's. All you have to do is copy all the x's for the latus rectum. For the movement of latus rectum going up, 4 plus 18 over 5, that will be 38 over 5. Then how about for the remaining part of the latus rectum? The difference. So 4 minus 18 over 5, that will be 2 over 5. Then how about for the second part of the latus rectum on the other side? Same concept. You're going to add and subtract on the y's. You also have 38 over 5. Then you also have 2 over 5. And how about for the directrix? The directrix will be x plus minus a squared over c, or 3 for the h, plus minus, you have the a squared, which is the 100 over 8, or c. That will have two value. So 124 over 8, or 31 over 2, and the other value will be negative 76 over 8, or negative 19 over 2. And how does the graph looks like? You have the center, you have the focus, you have the vertex, you have the latus rectum, and the directrix. And the directrix can be seen on this part. The 31 over 2 and the negative 19 over 2. Okay, let's have number 3. The given for number 3 will be y squared over 25 plus x squared over 16 equal to 1. We need to locate the different coordinate points of the center, vertex 1, vertex 2, focus 1, focus 2, the B1, B2, latus rectum or latera recta, and the directrix. Remember, the center of this equation of this ellipse is 0, 0. And the movement of this ellipse is a vertical major axis. How about for the B1 and B2 value? Remember, your V1, B2 is represented by B. So you have B equal to plus minus 4. So you have, since this is a vertical major axis, the movement from the center will be left and right. So therefore, changes in excess. So 4, 0 and negative 4, 0. How about for the vertex? The vertex is represented by A, right? For the value of A, that will be A squared equal to 25, or simply as A equal to plus minus 5. The movement of the vertex will be up and down, or change in y's. So therefore, the value of vertex 1 will be 0 and 5, and the other part will be negative 5. How about for the focus? If you have already the value of A and you have already the value of B, you need to get the value of c. So you have c squared, or the differences of 25 minus 16, that will be 9, and the square root of 9, that will be plus minus 3. Then the movement of the focus will be left and right for the vertical major axis. So therefore, if you have the center, this will be left and right, 0 and 3. Then you also have 0 and negative 3. How about on the latus rectum? The latus rectum, this will be changes in excess, right? So this will be b squared over a. So that will be 16 over 5, then 3. Then how about on the remaining part? Negative 16 over 5 over 3. Negative 16 over 5 and 3. And how about on the other side of the latus rectum? Negative 16 over 5 and negative 3. Then negative 16 over 5 and 3. How about on the directrix? The directrix will be a squared over c, or 25 over 3. Then how does the graph looks like? So you have already the center is at 0, 0. You also have the vertex is at 0 and 5. You have the focus is at 0 and negative 3 and 0, 3. Then your minor axis, this will be negative 4, 0 and 4, 0. And your latus rectum. And your directrix. 25 over 3 and negative 25 over 3. So the latus rectum and directrix. Let's proceed. Let's have number 4. You also have quantity y minus 2 squared over 25 plus x plus 3 quantity squared over 9 equal to 1. So we need to locate the different coordinate points of this ellipse. Center, vertex 1, vertex 2, focus 1, focus 2, B1, B2, latus rectum, or latera recta. So, and directrix. So, the center of this ellipse is negative 3 and 2. And what will be the movement of this ellipse? So, this is a vertical major axis. How about the value of b? B is represented by b squared, or b equal to plus minus 3. So, the movement will be left and right. So, therefore, changes in excess. So, therefore, 0, 2. And you also have negative 6 and 2. Remember, for the minor axis, changes in x for b. Let's proceed. Let's have v1 and v2. Remember, the v1 and v2 is represented by a squared. Therefore, a equal to plus minus 5. So, the distance from the center to the vertex, this will be changes in y's. So, therefore, plus 5 and minus 5. So, this will be negative 3. You also have negative 3 plus 5. So, 2 plus 5, that will be 7. And the other side, 2 minus 5, that will be negative 3. And how about for the focus 1? The focus can be solved by c equal to square root of this. So 25 minus 9, that will be square root of 16. And the square root of 16, that will be plus minus 4. So what will be the coordinate points of focus from the center? If you have the center at negative 3 and 2, then you have the focus, the two focus will be changes in y's. So therefore, 2 plus 4, that will be 6, and 2 minus 4, that will be negative 2. How about for the latus rectum? So latus rectum equal to b squared over a. So this will changes in x. So the changes in x. So all you need to do is copy all the x's for the latus rectum. So this will be b squared over a. So 9 over 5. So therefore, you have changes in x's. So negative 3 plus 9 over 5. Then copy the y's. For latus rectum 1 and latus rectum 2, negative 6 over 5. Negative 6 over 5 and 6. So, negative 3 plus 9 over 5. So, that will be negative 15 plus 9. That will be negative 6 over 5. Then, copy the y value. How about for the other part of latus rectum? You also have negative 3 minus 9 over 5 or negative 15 minus 9, that will be negative 24 over 5 and 6. So same also with the distance, negative 6 over 5, then 2, negative 2, then negative 24 over 5, then negative 2. How about for the directrix? The directrix will be k plus a squared over c equal to 2, the k, plus 25 over 4, or simply as there will be two values. So you have 33 over 4 and negative 17 over 4. So how does the graph looks like? So the graph of this ellipse, you have the center. The center is at negative 3 and positive 2, second quadrant. Then you also have the vertex 1. The vertex is 5. You also have B. The distance of B is 3. Then you also have the distance of C. The distance of C is focus, center to focus. That will be 4. Then you also have the latus rectum. Latus rectum. So, then you also have the directrix. So, the directrix is equal to y equal to 33 over 4. And the other value will be negative 17 over 4. So let's have the continuation of the other videos on